Okay, we're going to continue our work with systems by looking at some story problems, some real-world situations in which you'll use a system of equations to model this sort of scenario. So we want to read the entire problem. That's always important. Write two equations. Remember, a system of equations, we need two equations for it. And then we'll solve the system that we write from the problem. So let's take a look at the first one. We got the sum of two numbers is 36. Their difference is 12. Write a system of equations and solve. Now, anytime you read a problem and your goal is to set up a system of equations, it's important to kind of identify the information that you'll use for each equation. So in this case, we have the sum of two numbers is 36 and their difference is 12. Well, the sum of two numbers is 36. That's actually all the information we need for the first equation. So first of all, we know that a sum is adding. It's plus. And we have two numbers that we don't know. So we have x and y being added together, and the sum of them is 36. Okay, so that's the first equation. The sum of two numbers is 36. We don't know the two numbers, so they are x and y. And then the difference is 12. So that's the second equation. Their difference is 12, so x minus y equals 12. So now we have our system of two equations that we can actually solve here. And so we can use elimination. That's probably how we'll solve most of these. We're going to add here, and when we do that, the y's cancel out, so we have 2x equals 48. Dividing by 2 gives us 24 for the first number. And then we can use any of the equations to solve maybe the first one. 24 plus y equals 36. So we'll subtract 24, and y equals 12. And so our two numbers are 24 and 12. The solution here, we can write that as a point, 24, 12. All right, let's look at the second example. It says Leo bought 4 CDs and 2 DVDs for $70. Devin bought 1 CD and 3 DVDs for $55. Write a system of equations and solve to find the cost of each CD and each DVD. So what we'll have to do here, since we're trying to find the cost of the CD and DVDs, we know that's what our variables are going to stand for. So let's go ahead and use variables that make sense. So we can use C for CD and D for DVD. And you could use X and Y too, but why not? We'll use C and D. Now for the equations, we'll have to write two, one for Leo and one for Devin. So it says Leo bought 4 CDs and 2 DVDs for $70. So we know he bought 4 CDs, so that's 4C, because that's our variable for the cost of a CD, plus he bought 2 DVDs, so 2D, and his total was 70, so equals 70. So if we knew the cost of a CD and the cost of a DVD, we could plug those in for C and D, and this equation would be true. Now we need an equation for Devin. He bought 1 CD and 3 DVDs for $55. So that's 1C, or just C, plus 3D equals 55. Now for this system, which we now have, honestly we could go one of two ways. We could solve for C, since it's all by itself, and use substitution, or we can multiply this equation by -4, and we could use elimination. I think I'm going to go ahead and solve for C, because that seems a little quicker to me. We're going to subtract 3D from both sides, and C equals -3D plus 55. So I know that C is equal to -3D plus 55. And now I'm going to plug that into the other equation. So 4 times -3D plus 55 plus 2d equals 70. So negative 12d plus, what's that, 220 plus 2d equals 70. Combining like terms, I've got negative 10d. I'm also going to subtract 220 from both sides. So negative 10d equals negative 70 minus 220 is negative 150 divided by negative 10, and d equals 15. So we know the cost of a DVD is $15. But now we have to find the cost of a CD. So let's go ahead and put that into this one. C plus 3 times 15 equals 55. So C plus 45 equals 55. Subtract 45. And C equals 10. The cost of a CD is 10. And you could plug these numbers in to both equations and just double check. But I think we're good here. So the solution, we want to write out a CD is $10 and a DVD 15. So as long as you know how much of each item and how much the total is for each person, you can write two equations and find the value or the cost of each item. So let's keep going. Number 3, a school play was held on a Friday and a Saturday night. On Friday night, 42 student tickets and 76 adult tickets were sold for a total of $624. That seems like an equation there. On Saturday night, only 21 student tickets and 55 adult tickets were sold for a total of $414. So we have an equation for Friday and an equation for Saturday. It says how much were student tickets and how much were adult tickets. So that's what our variables are going to be, one for student, one for adult. So we can use S and A, but to be honest, my S's tend to look like 5s, so I don't like to use S as a variable. It's totally fine if you want to do that, but I'm going to go ahead and use X and Y here because my S's tend to look like 5s. I don't know. So I'll use X and Y. So for Friday night, we have an equation here, 42 student tickets, that's 42X, because that's what I said my student tickets were. Whatever variable you use, just make sure you keep track of it. So if you use S for student tickets, make sure you use S for both equations for student tickets. And 76 adult tickets, so plus 76, because we're adding these values together for a total of 624. So 42X plus 76Y equals 624. Now, Saturday's equation, there were only 21 student tickets, so 21X plus 55Y equals 414. So fewer people on Saturday night. Now we have the system, we have to solve it. I would say, in this situation, we should use elimination. Let's go ahead and multiply this by -2. So I'll rewrite my system. I got 42X plus 76Y equals 624. And then after I multiply by -2, I've got -42X minus 110Y equals -818. So now we have to add those together. So if we add these together, the x's will cancel. We'll get -34y here. 76 plus -110 is -34. And 624 plus -828 is what that should be. Should be a 28. 624 plus -828 is -204 divided by -34 is 6. So we get y equals 6. Now we'll plug that in to find x. So it doesn't really matter which one we use. Let's use the smaller one. So 21x plus 55 times 6, so that's what y equals 414. So 21x plus, and 55 times 6 is 330 equals 414. So we'll subtract 330 from each side. So 21x equals 414 minus 330 is 84 divided by 21. X is going to equal 4. So there we have it. The student tickets were $4. The adult tickets were $6. Okay, final example here. The sum of two numbers is 18, their difference is negative 26. So another sum and difference problem. So first of all, the sum of two numbers is 18, that's x plus y equals 18. The difference is negative 26, so x minus y equals negative 26. And just like the first example, we can just use elimination here. The y's will cancel. 2x equals negative 8. So x equals negative 4. Let's plug that into the first equation. Instead of x, we'll write negative 4 plus y equals 18. We'll add 4 to both sides. And y equals 22. So our two numbers are negative 4 and 22. So there is the process for word problems or story problems with systems of equations. Read through the problem, write two equations to make the system, decide what your variables are going to stand for, and make sure that stays consistent throughout the entire problem, and then solve the system using whichever method you like, substitution or elimination, and then you should get an answer that, if checked, makes both equations true.